Okay, welcome back to Physical Science Online Edition. Sorry about the moving camera at the start. I gotta adjust the camera angles a few times. Today we are doing our dry ice investigation, which you can find in Google Classroom. I am going to go quickly through these demos to try to fit it into my 5-minute videos. But if you need to pause at any point, rewind, feel free to do so, or email your teacher for help if you also need it. So this is dry ice. Dry ice is solid carbon dioxide. It happens when you get carbon dioxide down below negative 78 degrees Celsius, otherwise known as negative 110 degrees Fahrenheit. Here's a piece of regular ice to compare it to. Regular ice forms at 32 degrees Fahrenheit or 0 degrees Celsius. And you can quickly see the difference as to why dry ice is called dry ice. It doesn't become a liquid. It doesn't get wet. Whereas regular ice starts to melt, turns into water, liquid water, and kind of forms a puddle there. So that's our big difference. We also have a difference in color and that difference in temperature that I just measured. So those are some of your observations if you were in class. Your first part asks you to take this piece of dry ice and put it into a cup of water, of warm water. Yeah, it makes that weird noise when it touches hot metal. So I'm just going to dump it into a cup of warm water. And quickly we see what's called just a cheap fog machine. This is one of the ways they make fog for like Halloween or movie effects. What's happening in here is your solid dry ice is turning into a liquid, or a gas, sorry, going too fast. Turns into a gas. That gas is still super cold as it rises through the water. So that is not boiling. That is just it becoming a gas and rising through the water. And that freezes some of the water, and what you see in the smoke is actually frozen water vapor. So if I run my hand through it, I actually can pick up a little bit of moisture, and it kind of feels like my hand is sweating. So there's your first demo. Second demo can get a little bit messy, so I'm just going to throw it in a tub here. And this is just warm water with soap in it. So same exact thing, we just added soap. Cool thing about soap is that it captures those bubbles, that gas in the form of bubbles, and then the bubbles rise to the top because they're less dense. Sorry. And then they fall off the side because it's more dense than the air. So less dense than the water, more dense than the air. And the cool thing, if you were in class, is you can actually take some of the bubbles right off and play around with them. You can actually pop them right in your hand. It's kind of cool to do. You should be really jealous that you weren't in class for this one. So that's my fun bubbles with the soap experiment. Once again, this vapor, this gas that comes out of here, it's a combination of carbon dioxide gas and water vapor. Next demo, kind of the same thing, except we're going to try to capture the gas in a different way. So I got warm water in my flask here, adding a piece of dry ice again. It's doing the exact same reaction. It's just warming up, becoming a gas. And I'm going to try to capture some of that gas in a balloon. So if I go ahead right here, I've now sealed it all up. This is where I have to change my camera angle. And then it's blowing the balloon up. It's kind of cool. What's going on here? Well, same thing. The solid is becoming a gas. As something goes through a phase transition of solid to gas, it's gaining kinetic energy and it's expanding. It's taking up more volume. And then because my balloon up here is stretchy, instead of the pressure going up, it just expands the balloon and I'm capturing that extra volume. This whole balloon is filling up with carbon dioxide gas. If I would put a solid stopper on here instead, it would not do that. The pressure would build up and eventually the flask would explode if the pressure got high enough. So those are my demos with dry ice here. Once again, I know I was going a little fast. So as a reward, I'll do a little bit larger demonstration for you. Sorry, I had to grab some fresh water. And there you go. So this is something you could do for Halloween or whatever. Just kind of a larger scale version of all of this. And let's see if I can get a little tornado going. Yeah, I can get the little tornado going. I don't know if you can see that. Oh, I had it up a little too high. Some students taught me how to do that last year. So there you go. Hopefully that helps with dry ice and sublimation.